Sorry, I was just having fun for a minute. Okay, so let's talk about database services. So just so you're forewarned, we are only going to talk about like 2 of the services, maybe 3 out of the 10 that are available on AWS. If we actually go look at the console, what did that do with my console? Wow. We go look at the console because Michael apparently can't stay logged in. What we're looking for here is that pardon me, just one second. Wow, I'm running into all kind of MFA stuff today, I guess because I did actually just log back in, didn't I? All right. And it's just one MFA after the other. Okay, so we're logged back in. Now, one of the things that to note here is that when we go look at the console and we look at all services and we go look at the database section, notice that like we've got relational database services, we've got DynamoDB, we've got Memcache and Redis, which is what Elasticache is. We got a Neo4j compatible database, Graph database, which is what Neptune is. We've got a Ledger database. We've got DocumentDB, which is based off of Mongo, like it has like MongoDB compatibility, although MongoDB doesn't think so, so that's interesting. Key Spaces, which is Apache Cassandra. TimeStream, which I think is based on TimeDB, but don't quote me on that one. That one I'm not sure about. And then we've got MemoryDB for Redis, which is just a way to like run Redis in a very holistic way. But just to throw this off a little bit, there's other databases hidden around like under analytics. So Redshift is over here, which is a data warehouse. Cloud Search, I want to speculate, is based on Solr. This is actually a fairly older service in terms of when it started. And then we've got OpenSearch service, which is like a variation on Elasticsearch. And so there's a bunch of, and that's just the like clean ones. You know, we've got Athena, which can read S3 databases. We've got Redshift Spectrum, which can also read S3 files. You know, there's like other ones hidden in here. So it's more than just the official ones that are here. There's others kind of scattered throughout, right? I also just want to take a moment, since we were just talking about data transfer and migration. Here's the Snow family. Here's the transfer family. Here's DataSync. Notice that they added mainframe modernization recently, but look at all these database services, or sorry, migration services. They got server migration, database migration, application discovery service. Well, one thing that's not listed here is Cloud Endure, which is a company they bought that also does data center block level replication. Cloud Endure is an awesome, funky service. Just know that that's out there as well. But since we're talking about databases, just a key thing here is that there's more databases hidden throughout the rest of the services than just the ones here. We're only going to talk about 2, maybe 3 of the services. So that's part of the official class. Just be prepared. Okay, so here we are. And yeah, we're going to talk about database services. So here's the check-in. Question: what actions on this list are your responsibility if you run into a database on EC2, right? Yeah, so I mean, it's funny. It's like, it doesn't say like select like 3 or 2 or whatever. It's pretty much everything like you're stating. It's like, it's everything but A, right? So you're not responsible for server maintenance. By the way, I wish they would use different terms. I wish they would say host machine or like physical host machine maintenance instead of server maintenance. Because I mean, if it's a virtual machine, is still a server, right? I'm glad that you all figured it out. But data backups, OS patches, and scaling, that's all you, right? Now, if you decide to run it on EC2, you got all this responsibility. But what's the theme of all of this? AWS wants to help you with IT by taking operational responsibility, by taking installation responsibility, by taking patching and maintenance. They want to take all that from you. They want that. That's how they feel like they're going to take over the world, is by making it easier for you to just use IT and let them do all the IT work. So let's talk about the database services. Before I do that, I just want to make sure one more time, if I was a smart man, did I just enqueue the labs? Yes, I did. Okay, good. All right, here's what we're looking for. We have a new database services team. We discovered that there's a lot more databases in operations than we expected. We want you to support everything we have. What does AWS offer for this? What do we have for caching? What if I need to do migrations, right? What are my options? So what are the various services that can meet these needs? What's the difference between a relational and non-relational database? What if I need a data warehouse? What do I do for that? What about caching? And then migration, right? Those are the basics. Now, specifically in our original diagram, the things that we're talking about here are going to be specifically memcached and RDS. And then here we have DynamoDB. Remember last time we had Lambda hidden over here and there was like something else over here. These are database applications. These are data store applications. These are not block storage, not file storage, not S3 object storage. These are actual applications. They just happen to be data store applications. All right. So here's what we're going to talk about. We're going to just touch on all the services briefly. Then we're going to talk about a relational database. Then we're going to talk about a NoSQL database. Then we're going to talk about a data warehousing service, which is what Redshift is. Then we're going to talk about memcached and Redis for caching. And then we're going to talk about just briefly about DMS and the schema conversion tool. That's it. So database administrators are open to new ideas when migrating workloads. So they want to use the power of managed databases at AWS. Sorry, I had to use a movie announcer voice for that because I felt like that was movie worthy. Here are all the options. You just heard me refer to them. I forgot that was called the quantum ledger database. I feel like I'm an inferior teacher now because I didn't actually pronounce the word quantum when I had the chance. So I'm going to remember that for next time, the Amazon quantum ledger database. Moving on. All right. The only thing we're really going to talk about is these five. Okay. We're not going to talk about Apache Cassandra. We're not going to talk about DocumentDB with MongoDB compatibility. We're not going to talk about TimeStream. We're not going to talk about the Neo4j Neptune database. It's not really Neo4j, but it's Neo4j compatible. Okay, let's put this in your mind. If you need transactional SQL-based strong schema, tight schema, clearly defined schema, non-fungible schema data, then you're going to use a relational database. So RDS, and by the way, I don't know why they list Aurora as a separate product. I mean, it is cool, don't get me wrong, it's awesome, but it's a subset of RDS. There is no Aurora in the console. It's underneath RDS. Same with Fargate for that matter. I don't know why they talk about it as a separate product. It's underneath other services. Don't get me wrong, Fargate and Aurora are cool, but we're talking about RDS. So the relational database service is what you're going to use if you want to use SQL. Now that's if you want to do OLTP. So that's transactional processing. And don't get me wrong, you can do some OLAP with that if you want to. You can do some analytics processing. You can. But mainly it's designed for transactional processing. If you need analytics processing and you need massive amounts of parallelization, that's right. I just pronounced parallelization. You can use Amazon Redshift for that. Redshift is the data warehouse service. These are all row and column table-based services that use fixed schemas, and it's SQL everywhere. Now, with most of these, you can offload them and scale them by adding either read replicas, or you can add additional clusters for Redshift if you want to. But mainly, if you need to get these things from a read-write, like a writer capacity to go faster, you have to upsize your boxes. So you have to define a bigger box if you want to go scale on these. Now, I say that Aurora has a serverless version, which operates a little different, but most of this operates off of an EC2 t-shirt size model. So you got to scale them up, or add, if you need to offload read requests, you can add read replicas, but for the most part, you're going to go vertical scaling for these. Okay, so that's a relational database. Like, this is the table schema things that we're all used to, right? We're used to this. Relationships are enforced by primary and foreign keys that are all linked together. You're not going to restructure your data on the fly without catastrophe, right? This is a little different than the NoSQL or non-relational systems, which basically use a key value system, which says I look for the key and then I get all of the attributes associated with that key. Key returns value. Now, choosing the right key is important for NoSQL, because how are you querying? What if you're constantly just looking for the high score and you're not necessarily looking for the gamer tag? You might actually create another index or a table here where high score is the key you look for. Anyway, my point being is that this is a very simple key value data structure. You ask for all the attributes associated with a particular key and you get them back. Now, you can do server-side and client-side filtering, so don't let me make you think that you got to pull back every single value. You can get SQL-like specific if you want to just pull back certain attributes. But just know that in general, this is more focused on pulling back a big blob of data than it is about being super precise about that data. Now, the cool thing about NoSQL systems or non-relational systems is typically they can scale horizontally because they're not strongly consistent typically. They're not super concerned about having strong acidity, which is consistency, idempotency, durability, and atomicity. I know, you can look up acidity if you want to, but we've been using, by the way, SQL-based systems like relational systems like this for like 30 or 40 years. NoSQL systems didn't start showing up until the early 2000s, and they didn't really hit mainstream production until about 10 years later. So when you choose the data store, when you're choosing your database application, you really have to answer the question of, do I need strong consistency? What about durability? How does it resolve contention? Do I care if I will go to read data and there's a write in flight? Because by the way, with an RDS, with a relational database, if there's a write in flight, it's going to lock the table so you can't read it until the write finishes. Non-relational systems don't do that. So choosing between them, it really depends on how you want to scale, whether you want traditional schemas or non-traditional schemas, and whether or not your read writes are going to economically exceed what you can support on a database. Let's be clear. With a relational database, you can throw a lot of horsepower at that. But if it costs you $1 million to run a database that you could run on NoSQL for 50,000, that might be worth looking at. And what I'm seeing today across most architectures is that at a minimum, I'm seeing people run a relational database as the system of record. They're using a NoSQL database for fast leaderboards for loose, kind of data. And they're running a search database like Elasticsearch in order to get fuzzy search going really well, right? So just know that I don't think there's a one size fits all. I think all right. So then what about RDS? Because you just heard me talk about it. Wait, I'm not talking for a second because it says my internet connection is unstable. Can everybody hear me? Someone type in the chat or say yes.
You're back.
Okay. Did I freeze? Did I look like God, what was that guy when I was a kid? Max Headroom.
Yeah, you totally froze for a second there.
Sweet. I'm so glad I could predict it. Okay. So RDS uses EC2 t-shirt sizes to launch databases. And these are your traditional engines. Here's the funky thing. You can't log into these EC2 instances. You can't even see them. So what it's doing is it's running one of these flavors for you. Ignore Aurora for a second. Just so you know, Aurora is just a flavor of MySQL and Postgres for the time being. Just think of it that way. So Aurora is just a cloud version of Postgres and MySQL. So just when you see Aurora, just think, oh, that's just Amazon's Postgres and MySQL versions. But when you start one of these, you actually specify the size of the instance. Now, if we go to ec2instances.info, that website I gave you yesterday, you may not have noticed this, but in the upper right left-hand side, there's an RDS tab. So you can actually switch over to RDS if you want to. And you can actually choose your t-shirt size. So let's say I want to see what they have in the T3 series. Note that not all of the EC2 virtual machine sizes are available under the RDS tab, right? So when you want to start like, a MySQL database or an Oracle database or whatever, you get to choose the size that you want. Let's say that you don't really care about the machine. Let's say you need something with 64 gigs of memory. Here's your options. Let's say you need 64 gigs of memory and you need 8 processors. You can do this on the EC2 side of things too, by the way. So this will allow you to pick the system that you need, right? By the way, what's the difference between 10,000? Hold on. What's the difference between 10,000 megabits per second and 10 gigabits? Anyway, what's the difference there? Isn't that 10 gigabits? Anyway, moving on. So bottom line is that when you go to t-shirt size out your RDS instances, you're going to use sizes that look remarkably familiar because they're going to be database versions of what you see on the EC2 side of things. Remember, you can't log into these boxes. You can't even see them really. But at launch time, that's going to be your vertical limit. Now, you can add replicas. You can even add a secondary, which by the way, can't be used for anything. It's just there as a backup. But just know with RDS, you're going to have some vertical scaling is going to be the way you're going to go, unless you can offload your read output. Now, that's true for everything except for Aurora serverless, because remember, serverless means hidden servers. So I'm mainly talking about the EC2 version of RDS here. Okay. So all of this is EC2 based using invisible servers you can't really log into, but you can see them at launch time. Aurora, by the way, has an EC2 based version and it has a serverless based version. So keep that in mind. I'll talk a little bit about serverless for Aurora here in a second, but just make sure you know that there's a serverless version of Aurora. Now, here's an example architecture. I got a purple load balancer, which we still haven't talked about load balancers. We're going to get to that. And then you've got EC2 and I got EC2, and then those are talking to an RDS database, and the database snapshots are going to a hidden section of S3. One thing that pops up, by the way, is that RDS will ask you how long do you want to keep backups for? You can keep them for up to 35 days. If you delete that RDS database and all you've done is taken automated snapshots, it's going to ask you if you want to initiate a manual snapshot because it's going to delete all of your other backups. So just remember that if you use automated backups, it's only going to keep them for 35 days. And if you delete that instance, those automated backups are going to go away. So take a manual backup every once in a while. Okay, if you use an RDS database. I mentioned before that scaling with RDS is going to be vertical. So you're going to have to make the box bigger. Yes, you are going to take an outage. Just so you know, just to say this though, is that if you have a what's called multi-AZ enabled, you're not going to take an outage. It's going to upsize the backup box, roll all your connections over to the backup box. That might be an outage anywhere from like a second to 30 seconds. So don't trivialize that. And then it's going to upsize the other box. So just know, if you enable multi-AZ, you're basically telling Amazon that you want to run 2 boxes of the same size. One's going to be in one availability zone. The other is going to be in another availability zone. And this is synchronous replication. So Amazon's not going to let you do anything with that second box, because if you slow the second box down, it's going to slow the first box down. So you can't touch the second box. But if there's a failure, Amazon's going to automatically change the CNAME DNS entry to point towards the second box. You don't have to change your application in any way, shape, or form. Just make sure that application is pointing towards the CNAME for the RDS database, and it will automatically fail over to the new primary, right? By the way, I think if I remember correctly, when Amazon first launched this, you could actually access the second box, and they quickly found out that that was a mistake because people started running reports off the second box. And when you slow the second box down, it slowed the first box down, and then all of a sudden they disabled that. So, yay for beta. You have to find out these things. By the way, adding a multi-AZ box, adding a second box does not improve performance. They're going to test you on this. Do you understand that adding a second standby box is not going to improve performance? It'll improve high availability. It's not going to make your database faster. Yeah, I know. All right, one way to actually increase performance of a primary system is to get all the reads off of it. How do you do that? We'll create a read replica. Some of these, by the way, SQL engines support up to 15 read replicas. And by the way, they can be in other regions. And you can break the relationship between the read replica and the primary and then promote the read replica to its own independent database. This is kind of cool, actually. It's a great way to get a copy of production in another location, right? Just know that this is asynchronous, by the way. Excuse me. Did I mention that my desk is manual? Just know that this is asynchronous replication. So you can get replication lag between the read replica and the primary. It can be up to a couple seconds. It could be up to 30 seconds if you've put the read replica on the other side of the world. So just be careful. Yeah. A lot of people I know, by the way, are using read replicas to set up a great DR environment where they can literally just have it fail over to another system. So it's good for that because you get near real-time replication. So it's great. I feel like there's something else to say here. Hold on. Let me just look at the speaker notes here for a second. See if there's something else I really want to say here that was like super important. Oh, that is a new thing, actually. So just to mention this is that with MySQL and MariaDB, apparently you can now set up the read replicas has to be multi-AZ, right? Has a DR target. So then that way, by the way, if you promote the read replica to be a standalone database, it's going to automatically be replicated to multiple availability zones in the other region. That's pretty cool, actually. I didn't know that. So they just added a new note here that said that. So, that's cool. So now you can have multi-AZ read replicas, which that really promotes the DR scenario at that point in time. I wonder when they added that. That's going to be fun. Another reason to create read replicas, by the way, is so you can offload reporting. Don't run reports on your production database, right? Just copy it out. By the way, the read replica has to be the same size or bigger as the primary. So you can make a really fast, big reporting server, just run it for that lifecycle and then kill it when you're done. These database engines do support encryption. It is worth saying that I don't see that listed here, but like Oracle and MS SQL have what they call transparent data encryption, TDE, TDS, I think is what it's called. You can enable that, by the way, on these systems as well. One thing they don't mention, which they kind of should, none of these systems support clustering. So if you run an Oracle rack, you're going to roll that on EC2 yourself, right? If you want MS SQL log shipping, like you want some kind of like, you're going to run that on your own instance. They don't say that. Kind of hoping that someday they'll actually offer clustering, because I think they would do that really well. I think the problem they're running into is licensing. I think Oracle is probably a little less friendly than Microsoft around this, but I think my speculation is they're having trouble figuring out the licensing agreement in order to do that kind of thing. Otherwise, they would have done it a long time ago. Aurora is the subflavor of RDS. So don't forget this. So Aurora is a subflavor. So Aurora is AWS's like kind of cloud version of Postgres and MySQL. So, you know, consider this as an option when you're looking for a way to get more performance out of your database, but you don't want to switch database engines. And you're like, hold on, Michael, what did you just say? Did you just say I could get more performance if I used Aurora versus just using plain old MySQL and Postgres? And the answer is yes. So just so you know, if you take the same database with the same indexes and the same queries, everything, and you put it in Aurora MySQL versus just the standard MySQL engine, it'll run like 3 to 5 times faster, like proven. And the reason for that is that they're doing this special thing with the storage where they're actually pulling off the storage and they're writing directly to storage off of all these systems. And they're creating 6 database copies every time you write data and every time you read data. It's sick. They're doing this like cool thing. And this has been around for a minute, actually. And they're doing this cool thing where they're maximizing storage performance, which is really the number one thing that happens with databases. In addition, you can create up to 15 Aurora replicas, which also can participate in the read process, not necessarily the write process. So this is actually pretty cool. So, you know, this is not the coolest thing about Aurora, by the way. This is just cool. And this is all using EC2 t-shirt sizes. So we haven't even talked about serverless yet. This is still just standard Aurora, which in and of itself is a pretty awesome system. So note, by the way, that this is going to read data from multiple copies, and it's going to be way faster. So just know that if you're using Postgres or MySQL and you don't need like some super proprietary level of compatibility, you might want to look at Aurora to do this. Now, I say that this is what I would actually recommend. If you are getting away with MySQL and Postgres and you want to like experiment with something that's like, this is version 2, by the way, this isn't version 1. Serverless on Aurora is spectacular. So just know that if you don't want to manage any servers, invisible or otherwise, and you just want to like let Amazon handle the scaling of your database for you, and you only want to pay when the queries are run against your database, with these options, just to mention this, Aurora and others, you're going to run those EC2 instances underneath the covers 24/7. With serverless, you don't pay for those servers. You only pay when a transaction is run. And this thing used to be horrible. It had horrible cold start times from my perspective. And now it's super fast. So version 2 of this, which got released like 6 or 8 months ago, spectacular. So if you haven't touched serverless Aurora yet, I hope you get a chance to, because it's really good. So Christian, were you talking about this? Like, isn't this just a multi-AZ solution with recopy from 2 slides back?
Yeah.
No. I mean, yes, but no, not really. And the reason that it's kind of not like the multi-AZ solution is that they're not actually talking to the instances. The storage is actually being written directly to the cluster volumes on EBS. So in a sense, you're right. It is kind of like the multi-AZ thing, but the difference is they're not actually talking to the instances. Data is being written from the primary directly to the storage. So it's not, they're not talking to the operating systems.
All right.
So in that way, yes, it is exactly like multi-AZ, but not really. But to your point, though, it is technically multi-AZ because look, we're operating across 3 availability zones, right? So, you know, in that way, absolutely, right? So now we can withstand the loss of a failure. By the way, if the primary goes down, it will promote one of the other boxes into the writer, right? So it can actually take writes. So did I say no? I meant to say yes. You were right.
Okay. Yeah. What I was saying was that it looks like they suggested, hey, this might be some way that people are doing this. You know, we moved it to having a read copy because the read copy is faster. You know, you continue to write in your primary database. I move it off into these separate EBS volumes, and AWS went, well, you know, we could just go ahead and make that a service.
Right. Right.
And here it is.
Well, what's cool also is they give you a reader endpoint and a writer endpoint for your Aurora system. So no matter how many replicas that you add to the reader DNS entry, they're all added in there. And wherever the writer lives, if it fails there and gets moved somewhere else, you just access the same DNS URLs. So it's pretty cool from that perspective also. Okay, that was all RDS. Did I sound excited? I actually do like Aurora. I don't really like RDS, actually. Not because there's anything wrong with it. It's a great service. I'm just trying to move away from those subsystems. Okay. How do I set up a NoSQL database in AWS? Whew, that's a big question. There's like 6 that you could use. But let's talk about DynamoDB. So DynamoDB, by the way, is the database they use for Amazon Prime Day. I want to say it handles 10 trillion requests a day, 20 million requests a second. I think those were 2019 numbers. I don't even know what 2021 looked like. Maybe it was less, maybe it was more, right? But this is a fully managed service. If you ever, by the way, want to run the open source version of this, it's called RIAK, R-I-A-K. It's written in Erlang. Tons of fun to run in production. At least it was 10 years ago. I hope to never do that again. Maybe it's improved. Hopefully it has. I think there was a company called Basho, which is named after a Japanese poet that they, Japanese haiku poet that they based their service on. Anyway, RIAK. So the 2001, someone wrote a Dynamo paper about the distributed consensus and all this other stuff. They made a data store out of it 5 years later, 6 years later. So here you've got clients who are talking to a load balancer, and the load balancer is talking to a bunch of EC2 instances, and that in turn is talking to a backend database called DynamoDB. Now, the cool thing about this is that DynamoDB just works off the concepts of tables. And what are those tables structured? Well, this is NoSQL, so they're structured any way you want to. So for example, here's user ID and game title and top score and blah, 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 blah. And leaderboards is a great use case for DynamoDB. Constantly changing, data is coming in. No one's going to die if it's off by a few points, but you might want to let all the data settle before you determine a final winner, right? Use case number 2, shopping cart. That could also be session data, right? So in other words, you could store all your shopping cart items or all your session data, like session tokens in there, DynamoDB. Again, data that's not necessarily going to change, it's just going to expire, right? And then, tables can follow a variety of actors, roles, years. In other words, you can structure these tables the way that your clients are going to search. And by the way, you can create indexes on top of these tables, both local and global indexes that have their own independent performance characteristics, and you can completely change the composite and primary keys so you can search off of different characteristics. Secondary indexes are what they call those, by the way. There's global secondary indexes and local secondary indexes. Let's see, was there something else to say there? No. Other things to note is that just like EC2, which we haven't even really talked about yet, DynamoDB has this concept of auto scaling, meaning that you can basically allow it to scale for you either within limits, which is called provisioned, or on demand. Just let it respond to anything it gets. So an example, you can set auto scaling and say, look, this is the minimum level of reads and writes. This is the maximum level of reads and writes. Or you can say, look, if someone comes in and starts hitting my database, just give them whatever they want. They want nothing, give them nothing. If they want a lot, give them a lot. In other words, no limits. Most of the time, if you have spiky and unpredictable workloads, they recommend they're going to use on demand, right? Not provisioned. Provision basically says I'll only go this far up or I'll go this far down. Now, DynamoDB, other than basically the provision to scale read and write, writes per second. This is what this controls, by the way. This controls either reads or writes per second. What's the maximum? What's the minimum? Now, in addition, you can also control the amount of consistency that you're offering. So remember, I said that sometimes if you have a write in flight, you could get a read that's the old data, because this system is trying to sync up a bunch of different servers at the same time, and they are trying to be eventually consistent. Meaning they are not trying to be absolutely consistent. They're okay if they feed you out a read that may be out of sync, right? But if it's strongly consistent, this is when you come in and say, hey, I want to know for certain across all servers whether or not what this value is. We saw that before when we were talking about SQS, right? Is that when you come in and you say, hey, I want to know how much money I have in my bank account. It goes and talks to all of the replicas and says, hey, we all agree there's no rights in flight. Michael has $100 in the bank. That would be horrible. Michael has $100 in the bank, right? If you do eventually consistent, what will happen is it just talks to one system. Hey, how much money does Michael have in the bank? Hey, he's got $200 because my $100 transaction is still in flight, right? Now, let me be clear. The discrepancy between a read and a write doing that is going to be about, 100, 200 milliseconds. In other words, it's not going to take long for a write to apply and get replicated. But just so you know, if you're doing a highly transactional system, you probably want to look at maybe using strong consistency just to make sure that you're getting the most accurate number from the database. RDBMSs, by the way, are naturally strongly consistent. They don't give eventual consistency. Why? Because with an RDBMS, there's only one person that controls write. There's one entity that controls writes. So the minute something comes in and writes, it locks the table. Nobody can read from that table until it's finished its writes, right? Now, it might only be a millisecond, but it's going to prevent anybody from reading it during that time period. So bottom line, if you need strong consistency, you're going to use strong consistency. If you don't mind if it's a little out of date, then you use eventual consistency. I know. Some of you are horrified right now. You're like, when will we actually not care if the data was a couple milliseconds out of date? Yeah, there's scenarios. Hold on one second. All right, last thing. So if you need to globally replicate a table across the entire world, just know that you can actually use what are called DynamoDB global tables. These tables, by the way, are going to exist in every region that you put them in. And what's going to happen is that they're going to sync with a master table. There's going to be like a global table they sync up with. And that table is the global kind of like replication master table. And what's going to happen is everybody's going to be eventually consistent to that table and therefore to each other, right? So think of this as like they're like consistently hooking into this global table. And if someone makes an update in one region, that table writes to the global table. And then what happens is that the other regions are going to check in with that global table in order to get updated data. So this is global table replication. So bottom line is that this is only eventually consistent. It's not strongly consistent. It's eventually consistent. So if someone asks you that they need strong consistency for global tables, you can't get it. The only way to get strong consistency is to stick with a local table. Questions this far? Good. All right, the rest of these actually go pretty quickly. One, defining data warehouse. So a data warehouse is basically where you've got detailed relational data coming in, like from line of business and transactional systems. And usually what happens is that the aggregates are then, deduped, cleaned, enriched, and transformed into a single source of analytical truth. That's what we're looking for. So a data warehouse is typically where you store your most important data. It can be detailed. Usually it's aggregates, right? And this is used for operational reporting and analysis. How's the business doing? How much money are we making? Where is this coming from? What were our sales? Like, what are the, again, mainly aggregates, but it could be super detail oriented. It just depends, right? So very structured data, very much SQL compatible. Redshift is Amazon's petabyte scale data warehouse. And unlike the Snow family, this thing I think can house 3.2 petabytes of data. Now, you may remember that, Vinod, I think it was you, because I was talking to Sean earlier, is that you were asking about, like, are these using SSD backed ephemeral disk? And I found out actually that they are. So what's happening, though, is that the data is being replicated 3 or 4 times over, which, by the way, is one of the use cases for using ephemeral disk, like using the instant storage, right? But what's also cool about this is that not only is Redshift replicating the data, but it'll replicate the data with its clusters as well. So you can have multiple clusters running at any time. This, by the way, has this cluster on demand trigger where you can hit the leader node, ask for a query, it determines it doesn't have capacity and literally spins up another cluster just to run your query and then shuts the cluster down once it's done, right? So Redshift is a fully managed cloud native performance at scale columnar format warehouse. It's got strong transactional consistency, distributed query processing, all kinds of stuff, actually. It does automated and continuous backups to S3, which is another way in which it maintains data consistency. This has been around for almost 10 years. So next year will mark its 10th anniversary. If I remember correctly, 2012. Yeah, 2012. So this is really ideal for OLAP, not transactional processing, not OLTP, but analytical processing, OLAP, right? Use cases, predictive analytics, operational analytics, data as a service, like business BI is great for this as well, right? Now, one thing to know is that row-based storage is what we typically use for transactional processing. Columnar-based storage is what we used for analytics, for analytic queries. This is for aggregation. So this is great for this. Now, notice I said it will do concurrency scaling. So this is where it'll just add a cluster. Be like, hey, your query is going to overload what I have. I'm just going to start a new cluster and give it over to that cluster, right? So this is if you have concurrency scaling turned on. It will actually scale in and out from a cluster perspective. Pretty cool. Oops. There are, by the way, different like node types that you can use. There's the RA3 nodes, which is kind of like, they're like the new ones. It's kind of recommended that you use these. That way you can manage storage and compute somewhat independently because it's got scalable managed storage. It is SSD backed. And you just choose the number of nodes based on your performance requirements. Redshift will walk you through asking you about all of your queries and stuff to figure out how to size. So the Redshift interface will actually ask you questions like, what kind of queries are you going to run? How long you're going to run them for? How much data do you expect to ingest? It'll ask you questions so it can help you size based on the number of nodes. They do also have DC2 nodes, I believe now, which have the local SSD storage that we were talking about. When they released Block Express, by the way, this is what's backing up the RA3s. So you're kind of shifting away from that ephemeral instant storage with the DC nodes to now we're using basically Block Express as the underpinning for the RA3s. So you're seeing a transition away from ephemeral and instant space storage to what is still kind of in a sense ephemeral based storage, but now it's based off of IO3. So IO2 Block Express. All right, that's all Redshift. Woohoo!
Do you expect any questions from Redshift or DynamoDB?
Wait, say again.
In the test certification, in the certification test, do you expect any questions from Redshift or DynamoDB?
Oh yeah, they're going to ask you questions about local secondary indexes. They're going to ask you questions about strong eventual consistency versus other consistencies. You're definitely going to get questions. Now, if you're like, well, hold on, Michael, like we kind of skim this. That's what the practice exams are for. They're going to let you know which things you need to know about, right? You're not going to get deep questions on Redshift. You could get relatively deep questions about DynamoDB.
Gotcha.
Yeah. Okay. So let's say you're using caching and someone's like, hey, we already use caching with Memcached. Can I use another service? Like, can I use another open source caching mechanism? The answer, of course, is yes, you could use Redis, right? So database caching, as you can see here, there's no cache. And you might say, well, Michael, why do I need a cache? Can I just load it up into indexes? Sure. If you want to eat the memory for that, sure, you can do that. And I'm not against that, actually. I think indexes is a great option for making sure that complex queries are cached, right? But let's say you need something a little bit more robust, or you've got one primary database in one availability zone, and you want to reduce transit times by having caches in your other availability zones. You're not going to do that with a database, but that doesn't mean a read replica wouldn't be a nice option. But let's say like your use case is compelling and you actually need a cache in each availability zone for your application because you're trying to get down to single digit millisecond response time. And let's say that these queries that you're running are actually hitting your database pretty hard. Now, what you can do is you can actually stick a cache, and so the app actually goes to the cache first, and then it pulls the data back from the cache if it's in cache. Now, if it's not in cache, it's got to go back to the database, and it's got to actually grab, right, the data in question. Now, with caching, you accomplish this with Elasticache. Now, here's some strategies, though, to think about, is that if you put Elasticache in the database, it's usually what they call side-loaded, right? It's a side cache. And what happens is, let's say that you go to the cache and you're like, hey, do you have the results of this query? The answer is no. So the application then comes back, it goes to the database, gets the results, feeds it to the client, and then puts it in the cache. This is called lazy loading. This is one caching strategy. This is a cool way to do it because the only things that hit cache are things that you know you've asked for in the past. So it can be very lean, but this can result in a high cache miss to high cache hit ratio. The other option is that you can do write through. Every time the application updates the database, it updates the cache. That will result in fewer cache misses, but this means you're going to be sticking a lot more data into your cache, and there's a possibility that you're not going to be able to. There's a possibility that you're going to write things in the cache that you actually don't need. So that could be problematic. Because all of a sudden you could be consuming a lot more data in your cache and you're not using that data. Because does everything that is written to the database, every single thing actually need to exist in the cache? That's the question. Now there is a third option where you can just pre-warm or preload or side load, where you have another application whose job it is just to make sure that the cache stays warm. This is a good way to do it, by the way, instead of using the production application to do it, because you can actually check and see what's in the cache and just have this application managing the cache writes and reads. You can also, by the way, if you start a new cache node, have this caching application write all the data that's necessary from the database into the cache. So just so you know, there's the third option where you actually have an external kind of cache manager whose job it is to make sure that data is synced. So Elasticache is the answer for this kind of strategy where you want to cache in like sideload with your database. Now, I've run systems with and without caches, and we have downsized the size of our database because the cache was there. So just know caches can be incredible performance improvers of your system. So Elasticache is the service they recommend. Now, Elasticache comes in two flavors, Redis and Memcached. Bottom line is, and they're going to ask you questions about this on the exam, is that if you need advanced data types, pub sub, sorting and ranking, multi-AZ, and backups, you're going to have to use Redis. If they want any kind of advanced data type, you have to use Redis. Now, here's the thing that really chaps me up a little bit. They ask you a question that says, if you need multi-threaded performance or horizontal scale, they're going to use Memcached. So if you want pub sub capability, advanced ranking and sorting, you have to use Redis. If you want multi-threading and horizontal scale, you need to use Memcached. So make sure you understand those two distinctions, because they're going to ask you questions about this on the certification. You're going to say, hey, which of these is multi-threaded? Well, it's going to be Memcached. Which of these can scale horizontally? It's going to be Memcached. Which of these can do pub sub? Redis. Which of these can do advanced data ranking and sorting? Redis. Which one of these can do backups and restores and multi-AZ? Redis. Yeah. You've been forewarned. They're going to ask you a question on that, at least one, possibly more. So other thing to know, other than the actual Elasticache engines, is that remember that there's a time to live for these caches. So you can specify it, right? When you submit the value in, you can say, look, this is fresh for 30 seconds. After 30 seconds, go back to the source, right? So you can actually like bust the cache if you want to and say, look, this one's no longer valid as well. So there's ways, there's strategies that you can follow on how to, manage the time to live on these systems, the freshness of the data. That's what the time to live is, really. Other things to note with the DynamoDB accelerator, also known as DAX, this adds a read-only cache in front of your system. What does this do? So by the way, we've now switched off of like general database caches to a specific cache just for DynamoDB. This caching mechanism for DynamoDB is going to reduce you from single-digit millisecond response times for Dynamo to microsecond response times. So when you do reads, you can get microsecond response times, read times off of this cluster, right? So if milliseconds is too slow for you, which I know you're sitting there going, Michael, when would milliseconds be too slow for you? If you were doing like high frequency trading or something, or honestly, in a lot of military situations, you might want that to go as fast as possible. Just saying, right? So DynamoDB is going to be, with DAX, is going to be the thing you want to throw in here, right? So microseconds response time. Notice in this case, it's an online gaming site. I don't know, maybe Fortnite operates that way. I have no idea. Not really one of our key drivers here.
So, sir, is the DAX only for the read workload or for both?
It's only for reads. Most
Oh,
caches are only for reads.
Gotcha. And would that be like this one would be what? Right through?
Yeah, so
strategy?
DAX does maintain a relationship with the database that it's, the table that it's reading. So if the table updates, it's going to try and update the read almost instantly, right? So you don't really have to come up with a strategy for it because the DynamoDB table will trigger an update response inside of DAX.
Oh, I see.
Yeah. So you're still writing to the table, but your reads are hitting the DAX accelerator.
So this is a separate service, different charges, I guess, right?
Yeah, whole different set of charges
than Dynamo.
Yeah. Now I say it's separate. You can enable it. You enable it inside of DynamoDB, but your pricing takes a whole other different dimension when you enable DAX.
Gotcha.
Yeah. So DAX intercepts reads only. Writes are going to hit back to the table. Cool. Other questions? Okay. Database migration tools, right? How do we migrate databases to AWS? Well, guess what? There's really a couple of options, but there's really one good option. This is called the database migration service. This is for heterogeneous database migrations, right? Where you're basically converting from, MySQL on-premise to MySQL, right, in your data store, right? It can be used to migrate from EC2 to RDS to on-premise, right? DMS will basically, handle any formatting of the source data for consumption by the target database. It is not going to perform schema or code conversion, right? So, if you want to do heterogeneous migrations, like you want to go from MySQL to Oracle, then you're going to use the DMS tool, but only after you've used the schema conversion tool. So what it's going to do is it's going to convert the source schema to the majority of the database code objects into the target schema, right? It's going to, and any object that cannot be automatically converted, by the way, is going to be marked so you can manually convert it to complete the migration. This will also, by the way, scan your application source code for embedded SQL statements and convert them as part of the schema conversion. So it's going to like look at Oracle and SQL Server functions to their equivalent AWS functions. So it's also going to modernize at the same time. So once the schema conversion is complete, you know, it can also help, you know, figure out conversion from like data warehousing tools to Redshift. There's a bunch of things that it can do. This is just this isn't even a complete list of all the source databases you can go to from, or nor is that all the target databases you can go to. But you would do the schema conversion tool first, and then you would use the database migration service to help complete that migration. So two different tools that can help you facilitate database migration. DMS, by the way, will do one time or a continuous replication. So you can actually also use this to continually replicate your on-premise database with an AWS database as well. So it can also just dump stuff into S3 if you want to. So homogeneous is the easiest. Heterogeneous requires the SCT tool to really pull off. All right. Questions? Oh, our timing is perfect. So good. Okay, so what's the benefit of using RDS in a multi-AZ configuration? That's the question. What is the benefit of using multi-AZ for RDS? Good. Automatic failover across availability zones. That is accurate. Good. Yeah, so it doesn't provide cross-region replication, doesn't eliminate the need for read replicas, which is a read performance enhancement. 2 live copies of the database running concurrently. Now that starts to sound like Aurora. That's not accurate. But automatic failover across AZs, 100% on the mark. Okay. Which of the flavors of Elasticache offer sorting and ranking capabilities for data sets? Made a big deal out of this. Good. Yeah, so Elasticache for Redis. Remember, the only thing you need to remember about Memcached is that it will horizontally scale and it's multi-threaded. Redis is all of the other things. So, good. Which of the following is true regarding DynamoDB global tables? Why do we run global tables? What's the purpose? Yeah, I mean, we run global tables so that we can run tables in different regions that can actually sync up with each other, right? Why even call it global if we can't run tables globally? Good. What type of storage does Amazon Redshift use when it stores data? Not the local disk storage, but what kind of storage does Redshift use? Good. Columnar storage. That's right. Remember, that was the difference between row-based storage, which is what OLTP uses, versus OLAP, which uses columnar-based storage, which is Redshift functions off of. Good. All right, which of these are true about an Aurora database? Good. Yeah, that's the heart of Aurora, right? It has a serverless version. It's got the EC2 versions. but it's compatible with Postgres and MySQL. Good. That was the end of module 6. We're on to lab 3. Okay. Perfect timing, because by the way, this is a 30-minute lab, and we're pretty much at 30 minutes. So
Michael,
here's
what was the question? Just quick questions. What was the question on DynamoDB global table? Yeah. What is a table in the DynamoDB called global table, or?
So global table is basically you set up a global like entity, and what you do is you associate a bunch of different local tables with that global entity. And what happens is that those tables all stay in sync with each other by talking with that global table. So this allows you to run the same data set across multiple regions because they're each syncing with that global table.
Which is different from global secondary indexes?
Oh yeah.
Okay.
Global secondary indexes are local only. They're only inside of a region. Global tables is a world over replication, right?
Okay.
Yeah, it's a replication tool. Yeah, global secondary indexes and local secondary indexes are just used to cache information about a table that's already there. The difference, of course, as you probably know, is that global tables can use a different composite key if they want to. So they also have their own read and write performance characteristics.
Yes, I think my confusion is when we create a table in DynamoDB table, excuse me, in DynamoDB service, is that called global table, or to create the global table, what do we need to do?
Well, the first thing you have to do is you have to create all of your regional tables in DynamoDB first, and then you add them to a global table that you've created, right?
Oh, I see.
Right. So you have to have the table existing in at least 1 or 2 regions first before you can create a global table.
Oh, okay, gotcha. Thank you, sir.
Yeah. Okay. So if you haven't already, you can go ahead and click over to webage.quicklabs.com and go ahead and log into lab 3, which should be up and going. Here's what you're going to do. You're going to install an RDS instance. You're going to create a load balancer, define the load balancer targets and rules, test connectivity, and then test connectivity to the database. This is a relatively simple lab. It is considered to be a 30-minute lab according to the target. So on average, so go ahead and get cranking on that. Here is the general instructions: create a database, application load balancer, RDS, test, et cetera, et cetera. There's an optional task where you can actually create a read replicant in a different AWS region. That's kind of fun. But that's our focus for pretty much the remaining 30 minutes until we go to lunch. So go ahead and get cracking, and we'll go from there. I think there's just enough for all of you. I don't know why it failed to warm up all the labs in question. Hold on, that could be a problem actually. That's not awesome. A few of you might run into like a short provisioning time. I say short, it could be up to 10 minutes. Let me know if that happens, but God, there's not really a whole lot I can do about that. I don't know why it errored out and it did not do the entire 9 that I asked. So let me know if you run into that slowdown. It's not going to eat away at your time, but it is going to take some provisioning time to complete. All right, otherwise we're working on lab 3. When you're done, go to lunch. We're coming back at 1:03 p.m. I'll put that in chat. Otherwise, let's just keep going until we can get this lab complete.